Bridging abstract theory with dynamic reality. The evolution of field energy visualization. The core of the derivation sheet lies in transforming complex vector identities into a clear physical story about how energy lives in space. This sheet is structured through two distinct logical frameworks: the state diagram, which maps the evolution of a learner's journey, and the sequence diagram, which illustrates the functional integration of mathematical logic with visual software. The journey of understanding. The state diagram. The state diagram captures the progression from abstract definitions to deep conceptual mastery. It begins in the realm of theory, defining how energy density is calculated for electric and magnetic fields. From there, it transitions into static plotting, shifting the focus from equations to the physical reality of energy distribution. Here, the sheet highlights a stark contrast. The energy of a point charge is shown to fade away extremely quickly as one moves further away, whereas the energy within a solenoid remains contained and uniform. The journey then moves into dynamic animation, which breathes life into the math by showing the behavior of boundaries. By animating an expanding boundary, the diagram illustrates the increasing volume required to capture all the energy in a system. Finally, the process culminates in a conceptual explanation that provides the rigorous justification for why energy integrals disappear at the edges of the universe. The blueprint of proof. The sequence diagram. While the state diagram tracks the learner, the sequence diagram outlines the logical script that connects physical laws to the software demonstrations. It starts with the fundamental rules of the system, such as how fields relate to their potentials and how volume integrals can be mathematically transformed into surface integrals over a boundary. In its second phase, the sequence diagram acts as a bridge to the first demonstration, visualizing how energy density profiles differ between localized sources and confined fields. The sheet then enters a loop representing the software's animation of an expanding boundary line. This visual expansion is not just for show. It serves to confirm the scaling logic of the derivation sheet. It demonstrates that as the boundary of a system is pushed infinitely far away, the leakage of the field through that boundary eventually becomes zero. The essence of the derivation. Vanishing at infinity. The essence of the derivation sheet, which these diagrams support, is the mathematical proof that for localized systems, we can ignore the boundaries if we look far enough away. Because field strengths and potentials fade out at a specific rate as distance increases, the growing surface area of an expanding sphere cannot keep up. The sheet concludes that this specific balance, the way fields decay versus how space grows, is what allows scientists to treat the total energy of a field as a simple sum of its density over all space, effectively making the complicated boundary effects vanish into nothingness.